Given a line passes through A 3, 7, B 2, 4, and C 0, negative 2, and D negative 2, negative 8, right triangles are formed by using segment CD and segment AB for respective hypotenuses. Prove that the rate of change from point A to point B is the same as the rate of change from point C to point D. Read the following proof for this problem carefully and then follow the instructions. It is given that points A 3, 7, B 2, 4, C 0, negative 2, and D negative 2, negative 8 are on the line. Point F is made by the intersection of the vertical line through point D and the horizontal line through point C. Likewise, point E is made from points A and B. Okay, so I'm just looking at this graph, wanting to interpret it. Point F was made from the intersection of our vertical line from point D and our horizontal line from point C. Point E was made from the vertical line from point B and the horizontal line point A. Okay. Using the blank one, it can be proved that the distance of FD is equal to 6 and the distance of FC is equal to 2. Similarly, it can be shown that the distance of EB is 3 and blank 2. So if I'm going to look for blank 1, I'm going to select the options and think, okay, they had a blank and then they said it can be proved that we had a distance. So I'm thinking they're using the distance formula because that's what they have to use in order to prove a distance of a segment. So EB is equal to 3, so what were they using here? So they were doing FD right here, and FC is 2. And then they also had that E to B was blank 3, and so this blank 2, I'm having that it follows that it's going to be this horizontal distance of EA of 1, because we had a vertical distance and a horizontal distance, then we had the vertical distance. So I'm looking for EA is 1. So blank 2, EA is equal to 1. Alright, because the segment FD is a vertical line and segment FC is blank, segment FD is perpendicular to segment FC. Okay, well, what is segment FC? Oh, FC is a horizontal line. So, blank 3, I would be looking for a horizontal segment, because the line goes on forever, so horizontal segment. Let's see if that reads right. And segment FC is a horizontal line segment. Okay, so which means the angle DFC is a right angle. Similarly, segment BE is perpendicular to segment EA, so angle BEA is a right angle. Use the right angle theorem. It can be shown that blank. Okay, so they just said that DFC, since this was a vertical and horizontal intersection, that angle is 90 degrees. Likewise, this angle right here, BEA, is 90 degrees. Since all right angles have the same value, we could, using the right angle theorem, we can say that these two angles, DFC and angle BEA, are similar. So if I didn't know that, I would Google right angle theorem. So I'm looking for angle DFC is congruent to angle BEA. So angle DFC is congruent to angle BEA. So now this has BAE and this one has BAE. Which one would I select? I would select the ones that have these exact orders, DFC and BEA. So it will be BEA. Alright, so blank 5. The ratio of distance of FD divided by the distance of EB is equal to 6 divided by 3, which reduces down to 2. 6 divided by 3 is 2, so blank 5 is 2. The ratio of the distance of FC divided by the distance of EA is equal to 2, as well. Because the ratios of the corresponding side lengths of the adjacent sides of both triangles are blank, well, this one reduces down to 2 and 2, so they are both 2, which means they are congruent. So let's either look for they are both. Let's look at our options. For blank 6, increasing, proportional, the same, midpoint. Alright, so let's read this. Because the ratios of corresponding side lengths of the adjacent sides of both triangles. Okay, so ratios. In Geometry A, it is taught that ratios are proportional. So I'm pulling that from Geometry A. So blank 6 would be proportional. And if you were not in Geometry A last quarter, or if you were and did not remember that, please write that in. Ratios are proportional. And the included angles are congruent. Then triangle DFC is similar to triangle BEA by the side angle side similarity postulate. Alright, so that's saying that this triangle is similar to this triangle. So we're looking for blank 7. Because the triangles are similar, their corresponding parts are proportional. Therefore, the distance of EB divided by distance of EA is equal to the distance of FD, which is divided by the distance of FC equals blank. Okay, well, what is EB and EA? So EB again was 3 and EA was 1. So what is 3 divided by 1? It is 1. So that's how I would find blank 7. So this is 3. Okay, so because the distance of EB divided by the distance of EA is equal to the rate of change from point A to point B, and the distance of FD is equal to the divided by the distance of FC is equal to the rate of change from point C to point D, it is now shown that the rates of change are congruent, since 3 is the same as 3, not increasing, we're not talking about angles, the same. Okay, so the same is another way of saying congruent. So slopes can be the same, ratios can be proportional. So I hope that helps.